what's the code you see on Integrity?
It's 20150.
Yes, that's the semester for 2015. What's this code? 8833 RV.
8833.
RV?
Yeah.
RV what?
No one. Just RV.
Just RV? Okay. Weak 4 massing, weak 4 nested families. Let me see. Where it's uploaded. Weak 4 parametric massing impounds. This is what I have to do. There are like 5 classes created there. RV1, that's where it is. I need to put it to RV. Put it to RV2. And this guy. There are 5 sections created for some reason. So I don't know which one you guys see. I'm copying it all. So it should be available. See it? It's copying. It should be available in a bit. Okay. So today, we're going to do adaptive components. So far we've been working with curtain wall panel systems. So you have a flat surface, right? And you get some division. Let's say something like this. And in the curtain wall panel family, we have 4 construction planes, right? Which is basically the side planes of the panel. And whatever you do here, it gets replicated to all these. So the module stretches basically, right? So if I have something, let's say, like this, and maybe it's driven, like the extrusion is driven by some area parameter, so we can calculate W and H and calculate the area as a reporting parameter. We could then place these modules to all of those, right? That's kind of similar to the example that we yesterday. So that's how these systems work. So basically they're mostly extrusion based, but you can also utilize the rotation. But the whole surface has to be flat, right? So the difference between these and the adaptive components is adaptive components are more advanced, and you most of the time construct it through control points. So the control points are, we call them adaptive points. So let's say here we make a triangle. Each control point will have a number on it. Okay? And then they will also have 3 construction planes that are defining X, Y, and Z. The reason why the adaptive components are hosted by points is because the point ordering, so 1, 2, 3, is how you would place it in a host element, like a NURB surface. So if you had a NURB surface, and you got some division, let's say this is a triangular panel, you would have a pattern here. Let's say a triangular pattern, something like this. And this guy, basically this patch, will behave something like this. But since it has curvature in 3D, you would place these points, 1, 2, 3, and it will distort whatever this flexible element is into that configuration. Because each tile here is in a distorted 3-dimensional configuration, right? So if this is a NURB surface, you're extracting a tile, you're basically looking at the positioning of those 3 points. So that means in an adaptive component, these 3 points are flexible. They can be in any configuration. So that's why we lock whatever geometry you want to do for the panel to these 3 points, and the placement of those 3 points control the geometry of the panel. Yeah?
Okay, so 1, 2, 3, those numbers represent
The order of placement.
X always, 2 represents Y?
No.
Okay.
So 1, 2, 3 is the placement of the elements. So if I have, let's say louvers. Let's think about louvers, okay? That's the example we're going to do first. So I'm going to make a louver with 4 adaptive points. Let's say like this. 1, 2, 3, and 4. And I'm going to make a profile. And then this profile geometry will still undulate because they are hosted by these points, right? So they are controlled by these points. And then if I have an earth surface, and if I have control points here, which need to correspond somehow to that, so I have, let's say, 4 rows of control points, and these guys are actually going in this way, so there's like division. Then I come in here, use the adaptive component, and then place it in this order. So 1 is this guy, 2 is this guy, 3 is this guy, 4 is this guy. And Revit will look at the configuration of these points, and it will generate that panel to me here. If these points are making a curvature, 1, 2, 3, 4, this panel will be adjusted according to that. Because it's a flexible element, right? The thing is, these elements are hosted by or controlled by these points, whereas these panels are hosted by planes.
What is the profile controlled by?
The profile could be controlled by anything. We can also create parameters for it. So I could create a profile here, or import a profile, and control the thickness of that panel as well. But the point is, the thing that controls these elements are these adaptive points. There are only 4 control points. And the placement or the ordering of them is important for to generate them in the surface. I think it will make sense more when you see how it's done. But to let you know, first we're going to do an abstract element, but then the logic with the pattern-based systems is similar. So there are lots of pattern-based systems in Revit. So there you can do quads, diagonals. You could do offset patterns, something like this, right? But in each of these, there will be, like for this guy, there are 4 points. Those 4 base points are how we construct the object, and they need to be locked to those 4 points because those 4 points are going to distort and change on the surface.
The adaptive points need to be locked.
So no, the geometry has to be locked to the adaptive points because adaptive points are abstract, right? They can flex. This configuration could change. So if my geometry is locked to those points, then my geometry would distort according to that as well, right? So this point could be in any x, y, z, but I want to get that profile still. Okay? I think it will make more sense. I'm just trying to explain it through diagrams. It will make more sense when I do a quick example and show you how that works. Just so you know, it's a lot different than curtain wall panel families because they're more technical, more 3-dimensional, and you need to be more careful with snapping geometry and closing geometry. Okay, so let's start with a quick example. Let's do this louver first. So I'm going to go to the families, click on New Family, English 1, and I'm going to do Generic Model Adaptive. Generic Model Adaptive, yeah. We did the generic model, which is again, works with planes. Generic Model Adaptive environment is similar to the massing environment, where it's more 3-dimensional. So I'm going to open it. Now, we also have 3D planes here for construction. But what I want to do is something that is hosted by points so that we can flex the points and see how the geometry is behaving. So we can also create those points here. If you go to Create Draw, the point element is here. So I'm going to click on the point, and I'm going to put 1, 2, 3, 4, 5, 6 points. The ordering, the placement, the alignment doesn't matter. Actually, it's even better if they're not aligned. Okay? So now what I want to do is select all of these, and then you will see in the context ribbon under adaptive component there is make adaptive option. So it changes a point from being just a reference point to an adaptive point. So when you click on that, you will see that these points got numbers on them, as well as you can see the construction planes of all of them, right? So these planes are similar to the reference planes we've been using in Revit families. So you can snap objects to those planes. You could offset things from those planes. Yeah.
But you drew the points on the horizontal reference point, right?
Yeah, but it doesn't matter. It could be anyway. You could even draw them in an elevation if you want. Okay. Actually, that's the next thing I'm going to do. I'm going to like maybe draw some here and snap them to the geometry. So if I select any of these, I'll be able to move them around, distort them, give them like a three-dimensional position. Keep them linear for now. Then the next thing I want to do is show you how you can create a profile here. So if I come in here, if you remember, we were working with work planes, right? So we set kind of a plane where we draw geometry. So in this case, my profile is going to go in this direction. So I need something here, something maybe that is rectangular. So I'm going to do set, choose set to set up a work plane, and I'm going to come in here and choose the vertical construction plane. So it's going to be this guy. Yeah, I'm actually thinking if I should do it another way. Let's do it that way. I think it should be fine. Then I come to the rectangle tool. I'm going to click to the point and draw a rectangle profile there. And make this into a reference line. So choose all the lines you've drawn. If you haven't chosen the reference line option, go to the properties of the geometry and click on his reference line. Hit apply. So you get a green profile. Reference line, rectangle, but before doing that you need to set the work plane to the vertical, right? If I set it to the horizontal and I'm drawing in 3D, it will draw it on the horizontal plane. If you want to draw reference lines, you need to choose reference and line. But I did the rectangle. Okay, I'll do it again. Go to set work plane, vertical plane, choose this guy, because my profile is going to go this way. Reference line, rectangle, and draw a rectangle here. Now what you want to do is move the adaptive component and see that make sure that the profile is moving along with it, because that's the point of the adaptive component, so that even if the adaptive component changes direction or position, the profile will adjust along with it, right? So it's locked to that plane. Now let me see if I can center the profile there. If I move it, if I choose the rectangle, choose the midpoint, it still works, right? So I can do this. So center the rectangle, hit tab on the rectangle, choose all the lines, type in MV for move, choose the midpoint at the baseline and move it to the adaptive point. I'll do it again. I would actually do it separately. Set work plane, choose this plane, rectangle, reference line, just draw a rectangle anywhere on this plane, right? Because I'm selecting this plane, the geometry I draw will be snapping to that plane. And then what I did was choose the rectangle, type in MV, choose the midpoint of this line, and place it to the adaptive component. Right? And then make sure that when you move the adaptive component, the profile moves along with it. I'm making a three-dimensional construction. Okay? It's not a two-dimensional offset-based construction. It's fully three-dimensional, because I want it to behave flexible. Okay, then the next thing I want to do is create some annotation. So I go to create, dimension aligned. I choose this line, choose the adaptive point, choose the other line, and make this equalized. And then I'm going to create aligned again, give this profile a thickness in this direction and give it another thickness in the other direction. So this is going to be the depth of my profile. Depth. And this is going to be the thickness. If the text is too big, come in here, adjust your scale. So that's what I did. So the point is basically when I change these profiles, so let's say I want to have a panel that is 1 foot deep and 2 inches thick, like a louver, I will be able to adjust those parametrically, right? That's the profile. And the profile is hosted by this adaptive component. Now I want you to do it for all 6 of these. Yeah. Like a faster option would be to project these lines to these planes. And if you go to work plane, choose the second vertical plane of the second adaptive point. Then you can do pick lines, reference lines, pick lines. And if you choose these reference lines, you will get their projection. I'm doing a lot of geometry, so I'll do this way. Pick lines, reference lines. If I come in here, choose all of these profiles, I will get its projection to this plane, right? If your initial points were aligned, it would work, but since mine are distorted in 3D, you can do it this way as well. And you don't want to lock those. You want to do the same movement here. So I do MV. I want to move this midpoint to the adaptive point and do the same annotation here. And make sure that this profile is also locked to the second adaptive point, right? I'm drawing the same profile 6 times so that it controls how this geometry is going to be created. Okay? So I do the same thing here. So I do create, aligned, equalized. I want a vertical parameter and I want a horizontal parameter. This guy is going to be thickness. This guy is going to be depth. If I give it another profile, if I give it another parameter, then I can control also how the thickness of the louver changes through this interpolation, because I'm going to loft these profiles. No. So I'm going to do it as well. So I do set work plane, set this vertical work plane, reference line, rectangle, draw a rectangle, MV, move this midpoint here. And then annotations, right? Aligned. These guys would be equal. This overall width is going to have the same parameter. This depth is going to have the same parameter. Set work plane, reference line, pick lines, hit tab to choose all the lines, get their projection. You don't want to lock it, but you want to move it. So I type in MV again. Midpoint is going to be here. Create, aligned. This is equal. This is parameter 1. It's going to be parameter 2. Again, set work plane, vertical, reference line, pick lines, get their projection, MV, this moves here, create aligned, this is thickness, this is depth. They need to be located here. So that should work. I'm going to do flexing as well afterwards to make sure that the profile is working. Okay, set work plane, vertical. Reference lines, pick lines. Create, aligned. This is equal. Now this guy is going to be depth again, this guy is thickness. Make sure that you have applied the same annotation parameter to all of these dimensions. So this guy is going to be thickness, this guy is going to be depth. Thickness, depth. That should be fine. Now I'm going to move some of these and make sure that the profiles are moving along with them. So let's move this guy in this direction. So that's moving. This guy, let's move it in the other direction. That's moving. This guy is moving. So it should be fine. Now let's flex it as well. So the depth, let's make it 2 feet. Thickness, 6 inches. Hit apply. Hit OK. And everything is flexing correctly. This guy is not flexing correctly, so I find a mistake as well. Right, so this guy, I forgot to make this equal. So now it's working as well. Alright. And if you got to this stage, what I want you to do is choose all the reference lines and make it into geometry. So you choose the first profile, hold Control, choose second one, third one, fourth one, fifth one, and sixth one. And then click on Create Form. You'll get a loft through them. So that's going to be my louver. And the point is that when I move these control points, the louver flexes, because it's a flexible adaptive component. Okay? So the distance between each of these control points could be different. The three-dimensional configuration could be different. Okay? Let's how to do that. So my reference lines are placed on reference planes, and my reference lines control the lofted geometry, right? So my lofted geometry is locked to those. So when my points are changing, my reference planes are changing, so are reference lines, so are the geometry, so is the geometry. Does that make sense to everyone? Anybody has any questions? Yeah. I'm going to do a reference plane. I want to draw one here. Then I'm going to do pick lines, reference plane. Maybe I want to do a few more sections to control the geometry of my NURB surface. So I'm going to do offsets. Let's say 20 feet offsets. So I'm going to go right. I mean, these reference planes could be placed or locked to your grid lines as well. No, this is a new project file. So, and I'm doing an in-place mask to create a surface, and I'm going to bring in my adaptive component to use on it. Okay? And I'm going to do a horizontal reference plane as well. So I'm going to do one here. So now if I go to an elevation view, this is the front elevation. If I go to east elevation, I'll be able to see the sections of the profiles. So this is where my facade is going to be, and I'm going to draw a profile here. So let's say we have a few more levels. So it's going to be up all the way up here. I'm going to go to the east section. Oh, but before doing that, let's go to the plan view where we have been drawing these. Again, I'm going to do set work plane to set a plane where I'm going to draw the contour of the surface. I'm going to do a NURB surface here, and this is maybe the border of my existing facade, and I want to do some curvature here. I'm going to do set work plane, pick a plane. I'm going to choose this guy and open it in elevation view. Let's say east elevation, and I'm going to draw a profile here. Let's say that profile is go to reference line, spline. I'm going to start here, and let's say it's something like this. It's going to be a few stories high. Now let me see if this works, but actually I can draw different profiles, right? So if I go to set work plane again, pick a plane, choose a second guy, open it up in elevation. I see the previous profile. I could do pick line to make a copy of it, but instead I'm going to draw a new one that is slightly deviated from that. So maybe this guy goes in and it comes out here, so something like this. Now if I see it in 3D, I have those two profiles lined up, right? So I need a few more so I can loft that into a surface. Does this make sense to everyone? Sure, I'm going to do it 5 times anyway. I'm going to go to the south elevation, set work plane, pick a plane, come in here, open it up in elevation again, spline, reference line. So maybe this guy bulges a bit more, and then comes in. So my 3 profiles are drawn. I need 2 more. Set work plane, pick a plane, pick the reference plane, reference line, spline. This guy's like this. And last one, set work plane, pick a plane, reference line, spline. And that's the last profile. So if I look in 3D, I have 5 profiles lined up. And what do? I choose all the 5. Choose create form. Boom. I got a lofted surface. So it could be like a skin, basically. Right, something like that. Now I'm going to choose the surface. And here I have divide surface option. I'm going to choose that. So how many control points we had on adaptive component? 6. So what does that mean? That means I need to have 6 points on the surface if I wanted to go from here to there. Right? I mean, I could technically have 100 points here, but in order to use the adaptive component, I need to choose 6. So the way I choose it would affect the resolution, right? So in order to make it a bit more clear, I'm going to limit the vertical number of points per row, per column, into 6. So my horizontal grid is going to have, vertical is going to have 5. So I have 1, 2, 3, 4, 5, 6 intersections. And my horizontal could be any number basically. So I could do 80. And I think I could even parameterize it. I can make this number into a parameter too, if I want it. So I can make it into a parameter. But you can also control it manually, so it doesn't matter. So I have basically lines now that divide the surface. Yeah.
What number are you making in terms of control point? 6?
Yes, so each intersection of these lines is a point. If you want to see them, go to surface representation, click on this drop, and enable nodes. Those are the points on the surface that have u and v coordinates, right? So my adaptive component would be snapping to these points, right? So I'm going to say this adaptive point is this point on the surface. This adaptive point is this point. And then Revit is going to use that information to generate a flexible panel here for me using the adaptive component constraints, thickness values and other types of extrusion values, the profile. Okay? So the way it works, did everybody get to this level, or you want me to wait? You want me to do it, or you want me to wait? Huh? Choose a surface, go to surface representation, turn on the nodes. Yeah. Okay. See how I'm doing it? I'm going to go to create component, load family, desktop, adaptive louver, hit open. Now I got it as a smart object, and look at what the adaptive component is doing. its control is anchored to the first adaptive point. So it's asking me to place the first point for this adaptive louver. Okay? So I'm going to choose this guy here. And then I'm going to choose this guy, second point. Third point. Fourth point. Fifth point. And then sixth point. And it will place the adaptive louver there. And I can do flip as well. Let me see, what did it do? For some reason it did it this way. Huh? Create component, load family, just bring it in. Okay? If you place one, that's all you need. You can then choose the component and you can come to modify option. There is this repeat tool. And if you press that, it will just repeat the same process to all the control points. So it should do vertical louvers along this line. So however, like if I had 60 divisions, I'll get 60 points. So now I have my louvers placed. Yes. So select the surface. I have U and V grid. My V grid was set to 5. U grid was set to any value. So it could be any number of louvers you want. It's basically, let's say, edit type. I'm going to choose everything. Filter, check none, repeater, divide surface form, apply, okay, delete. So I got rid of my adaptive point. Now, the point with adaptive components is, again, I can put it anywhere I want, right? So if I did my component this way, I come in here, choose first point, second point, maybe I go here for the third point, to the second row, and then go down here, then go back to the original and here. It will still work, right? Because I'm specifying which points to use from the surface. And if I do pattern, the repeat, now I would have tilted panels, right? It will use the same type of information and replicate it. Do you guys see the difference? So instead of choosing these guys, I went with the first 2 points, but then shifted the second 2 points, and then went back with the last 2 points. Because I have an adaptive component, I can choose any points I want. Right? And now I have also a wave going in the other direction. Yeah. Oh, to this? Well, this doesn't have a material parameter, right? Why? Because it's not put in the family. So I have to go to Edit Family, choose the geometry, and give this material a parameter so that I can override its parameter in the file. Is that what you're asking?
Well, yeah, I was wondering if you could apply a material to this.
Yes, you can, but you need to define a parameter for it. Right? Same thing as how it works in the curtain wall panel families. Yes, I can add a parameter here, material. Material. You can make an instance, hit OK, add it. Now I'm going to load it to the project. It's going to override the existing. I didn't make it anything. It's going to be generic, so I can choose one in the project. Right? What do you want to choose? Wood? Now if I choose one of these, I'm using the tab key. Let me see. Where is my parameter? Edit in place. Material is now an option for me to choose, right? So I can come in here. What do we want? Cherry? Okay. Now it's wood. Now if you don't want to see the surface, you can turn off the surface. Let's see. And finish mass. And then inside your project, let me see. Edit in place. Select the surface. There's no, not that one. Should be able to hide it. If I do void form, you don't have to do it void form. You can just, right click and let me see, where's the hide? I'm trying to make it go away actually, so that we only see the louvers, right? You don't want to see the surface when you render it. Well, it doesn't show me the hide option. Let me see. Say what?
I don't see that back wall.
Oh, the back wall?
I think it's probably somehow where you follow it.
What do you mean the back wall?
The thing you're trying to hide, I don't see it on.
Oh, okay. You don't see it in yours? This should do it actually. When I turn off the surface option, it should already hide it. I'm trying to find visible. No, that's the reference line. I think it was one of these. Oh yeah, I can't do void challenge. Yeah.
Once you bring it in, how do you make it back? Repeat along with the loss.
What?
So I brought my.
Oh, choose one of the components. Choose that component. And then under the modify tab, there will be a repeat option with a letter P on it. Do you see that? right? And if I turn on the surface option, these were the divisions we have created. And if you look up the properties, it says no pattern. But if you click on this drop down, I have a bunch of surface pattern options here for tiling systems. So for instance, if I choose 1-2 step pattern, I will get a division that is like this. And if I turn on the surface representation, let me see, actually you won't have to do a surface representation. Basically, you would bring in a pattern-based family with this pattern logic, and you could use it to populate panels in this pattern. Okay? So, for instance, if I'm using 1-2 step, a hexagon, it will also snap to surface points. So let me change the vertical division. Let's make it 25. I'll get more pattern, right? So if I use a hexagonal pattern family, I'll be able to create it on the surface. But be careful, because you have also half tiles. You will have to patch these up somehow. Like, you won't be able to use the whole surface to tessellate the pattern. So let's look at some other stuff like the triangles. You could have triangulated pattern, and this controls how many tiles there would be, because it's also controlling the number of points on the surface, right? So these will be modules. So this will be a tile, and there will be like, let's say there are 200 tiles here. Each of them would be an instance of that adaptive component with a tile pattern family. Say what? Well, that's the point, because it's a flexible element, right? So it could fit within the grid. So if I have a triangle tile, it will use these grid points. So it will subdivide these squares into triangles to give me the pattern. And basically that's what Revit is doing. So it places these UV coordinates of the control points for division. So the one that I control here, so I have vertically 25, horizontally 80 points. And then if I choose any type of pattern here, it will use those points to give me the corresponding pattern configuration. Yeah?
You changed the color of the material before you changed the pattern, right? Like the color of it?
This is just an abstract display of an existing, like, surface pattern. These are not panels.
Well, no, I know, but when I changed my pattern, it's like it's not a color. Like, how did you change the color before you changed the pattern? Like, mine's just white, but it's not.
Go to this option under pattern, drop down here. You can like turn on the fill, turn off the fill, visualize the lines, or even toggle on and off the pattern. Right? So right now I don't have a component, so I cannot turn it on and off, but we'll bring in a component soon. Okay, so this is kind of some of the examples. So the rectangle checkerboard is basically going to use the tile you're going to generate on some of these, right? So the solid panels are going to be used. The void panels are not. So if you use this pattern family to create a panel, it will be only placed on these solid panels. So it's like on and off pattern. It's a checkerboard pattern basically. So it's zigzag. But these are all grid-based patterns, right? Because they're using the points of the underlying surface. So let's make one. The one that I like using is the 1-2 step, because it can create really like shifting, tilted panels and patterns. Sometimes it looks really nice. So I'm going to make a family and bring it here and use it for this type of division. So to make one, we have to go to Revit New again, Family. And this time we're going to work with generic model pattern based. Right? So if you open generic model pattern based, this will be the environment now we're going to use. So as you can see here, we have adaptive points again, but we also have an abstract representation for the surface grid. And if I choose this grid, it shows me the current pattern is rectangle, and you'll be able to choose one of these patterns here as well. So if I switch to 1-2 step, it will extend the pattern, and it will give me 6 control points, because that's how much space that pattern occupies. If I choose, let's say, arrows, the pattern is even further extended, right? Because this occupies a 3x4 grid tile, and then uses that grid. And how many control points? This has 8 control points to place this pattern. Let's look up the triangle. So choose the surface. If you go to triangle, bent, the triangle has 4 control points, and it uses 2 spaces of the grid. So basically there would be what the surface configuration would be, like, right? It's showing me how much space this tile occupies within the surface grid, and it shows me how many control points it has as well. So the triangle needs 4 control points, but if I choose something more complex like the hexagon, it needs more space, right? It needs 2x3 grid space, and it has 6 control points, and these control points snap to the grid. Right, so this guy will be copied. There will be another version here, another version here, another version there. It will keep tessellating the surface. Does that make sense to everyone? Huh? Please ask me any questions. Like, I'm serious. This is really important. You need to understand the logic. Yeah.
To fabricate this, what do you mean?
Fabricate?
Yeah.
What do you mean fabricate?
Like send the information to the fabricator. Is it shop drawings or this?
Oh, well, that's a good question. So you would basically prepare documentation for how this family works, right? So you would actually do, if you're doing a parametric facade system, there will be a single drawing per component, I would say. Yeah. And it's a bit tedious, actually, to extract those. I would say you could approach the question this way. If I'm modeling this in the parametric modeling environment, and I'm parameterizing how this tile works, right? Like the profile of it, extrusion of it, values that are happening on it. Like there could be a dimension here, another dimension here, angle here, profile thickness, all of those. You would basically export an Excel sheet with all those numeric values, right? So what the fabricator gets is they know they're doing a hexagonal tile, and there are edge values, as well as angle values, as well as thickness values. So how many values do you think there will be? A lot, right? But what they could do is they could take the values per row, per tile, and plug them into their system and see what that tile looks like in 3D, and they can fabricate it that way. Either they could make a negative mold form, or they could just build it out of linear elements like steel members. Right? So that's actually a good question, but it's super technical. So the documentation is something else. But just work on constructing it, understanding it, how that works, how to build it according to these control points and snap it. And you don't have to do this. I'm showing you advanced stuff because you can do these in Revit. And these things actually need practice. You need to practice these to get better at them, yeah. This is all repeating, yeah. Which ones? Rhomboid checkerboard? Yeah. So it will be the same way, the way I highlight it, right? This is the grid. So the checkerboard is placed diagonally. So it's depending on the connection and the placement of these control points, actually. Anything. Like the... Oh, sure. Oh, you mean... Okay, so I haven't worked with these a lot. Like, I would say these are already built in as voids. They're not solid. I don't see a built-in parameter for it. There's visibility parameter, of course, but you could do it per panel if you want. If you make an instance parameter, you'll be able to choose individual panels and make them disappear. Right? Is that what you're asking? But this is a... You have to look at these patterns as automating the process, right? You know you're dividing the whole facade as a grid system or as a hexagonal system. And if you generate one tile, you'll be able to replicate it to the whole thing. That's basically the idea. Let's do a quick example, and I think you will have more questions. Then we can discuss it more. So I'm going to do a 1-2 step family. And what I'm going to do is something like going to come in here, set work plane. I need to find those 2 points that are going to float above the panel, where the panel extrudes to. So I need to find first, I need to set the work plane to be the vertical plane of number 2. And I'm going to place a point there. And if you choose that point, if you move it up, you will get this offset value, which is the distance of this point from that plane, because that's where I placed it. Okay, if I move this up and down, you see that value is changing. And I'm going to make it into a parameter. So let's call it offset 1. And I'm going to make it a type parameter. You don't have to annotate it, because the way I'm placing it enables me to parameterize it under the properties of that point. It's offset from a reference plane. I'm going to do the same thing here. Go to set work plane, choose the vertical plane of point 5, put a point there, and I'm going to choose that point, move it up, and its offset value is here. And I'm going to define it as something else. Let's call it offset 2. Now if I choose point 5, type in MV, and move it up, that point will be moving with it. It's going to maintain that parameter that we have set, right? So wherever this point is going to be in 3D, that relationship will be set. So I'm going to do that type of flexing in this family as well. So I'm going to flex some of these points to see that they're behaving. Yeah? Sure. Set work plane. Choose the vertical plane. Place a control point there. Okay, I'll do it again. So set work plane, choose this plane, place a point to the origin of the adaptive point. Then use the tab key to choose that point that you just placed, which is here. So you will see the arrows. If you move it up, that offset value is here. And if you click here, you could associate it to some parameter. Right, so this could be like anywhere in space, this could be anywhere in space, and we can control that with a parametric value. So if I go to type properties, let's say offset 1 is 1 foot, and offset 2 is going to be 2 feet. Well, that's not too big, but it should be okay, because my panels are not going to be that big in the project. Actually, let's make them 3 and 4. 3 and 5 for now. So they're a bit more offset. Now the next thing I'm going to do is go to reference line. I'm going to connect these 2 points. In order to do that, I need to enable 3D snapping, so that I don't have to set up a work plane, right? Because I'm connecting 2 points that are located in 3D. So I enable 3D snapping. I'm doing a reference line, and now I'll be able to click on these points and draw a line between them. Right? So I do a bit of flexing as well. So if I come in here, enter 2 feet, hit apply,
that line is going to flex with those control points. And the last thing I want to do is choose this line, and then choose this line, type in create form. Well, this gives me something curvilinear, but if you want something linear, you could choose these two, do create form, and choose these two. I mean, you can do it separately basically. Create form, you'll get the panel, right? So this is, again, points are related to adaptive points, lines are drawn through points, and geometry is snapping through reference lines. So that's how things are constructed. So that's the same hierarchy. And let's do a bit of more flexing. So I do 3 feet, so the geometry flexes as well. I'm going to do is save this as a folded panel. And I'm going to bring it in to my project. So go to view, let's close everything. That file is, where is it? It's here. I'm going to do load into project 1. Now when I choose my surface, if I go to the pattern option, the folded pattern will be added under 1-2 step family, because it's another variation of 1-2 step family. And if I choose that, I have a lot of panels, so it's taking some time to generate. Yep. So that's what I got. So let's select the surface again and change the number of divisions. So let's say I have vertically 5, no, vertically, how many control points? Let's say vertically 12, and horizontally, you want to do them together under the properties tab, not here, so that you can hit apply. Yep, so that's I reduced the vertical division. I'm going to reduce the horizontal division as well. Let's make it 60. And if I go to edit type, I can also control those 2 parameters I set for it, right? The offset values. So let's say the offset, first offset is going to be 2 inches. The second is 4 feet. So it's going to tilt and open. So this is like looking like a weaving pattern. Now it's going to look like scales. Right, so the facade will be closed on this side, and it will be folded and open to the other side. Because the offset value of this point is really low. If you look up here, this is actually the right way to look at the facade. So that's like how it looks like now. And this is one pattern, one tile, right? So the offset value I set is this offset. I can make it 0 as well, so that it will be, let's see, so this gap will be closed and this gap opens, so it's now a tilted panel. Yeah, I added offset values for those 2 points. So that's how I'm making this into like weaving to a scale pattern. Now, if I choose this guy, go to edit family, maybe I don't want these 2 surfaces to be warped. So what I could do is choose this geometry, choose a single surface, and choose add edge, add a diagonal edge here, so that now it's divided into triangles. I can do the same thing here, add an edge to here. So now these will be flat panels, right? And I'm going to load it back to the project and overwrite the existing version. What happened? I lost everything. Okay, there it is. So now these are faceted, right? So they're triangulated. Now, if you look at the facade, there's a problem we have, which is around the edges. So some of the grids are half of the grid, so we don't get a full panel basically, and that's set by, if you go to the massing option again, if you choose a surface, we have a border tile option which says partial. What Revit is trying to do is basically it's extending the surface and assuming there's a half tile there, or tries to visualize the tile that it can place there. So if you make it empty, hit apply, you're going to see all the border tiles being removed. So now those are basically taken out, right? So if I go back to surface representation and visualize the surface, these quads are empty. Why? Because we can't fit a pattern there. We can't fit the full tile there. And what you need to do is basically do patching there. You need to patch it up with some other adaptive component, and that could be a single rectangle pattern family. So I'm going to do another one. Go to family again. Go to generic model. You can make adaptive or you can do pattern based. So just choose this guy and do create form. Make it as into a single surface. So when you do create form, Revit gives you options whether you want to extrude it into a solid or make it into a single surface. Then you can choose a surface, and then let's say we divide. Can we divide? Add edge. Let's delete that surface. I'm going to create form again. I can't divide it for some reason. If not, you could just draw a rectangle line like this, and then choose these, make it into a triangle. Choose this, make it into a triangle. So this I would use to patch it up, because there are 4 control points there. And I'm going to save this, call it patch tile. I'm going to load it into the project again. And if I go to create component, the rectangle patch tile is here, and I can put the 4 control points, right? So I can go here, 1, 2, and Revit is previewing what's doing as well, 3 and 4. So I'll be able to place it there and close it up manually. Why? Because I cannot fit 2 patterns in one surface. So I need to specify how that works. And this should be able to repeat as well. Let's see. So if I press repeat, you should be able to fill in those gaps. Does that make sense why we're doing the patching? Yeah, so now the bottoms are patched as well with that tile. So now I have a full closed surface. Well, I'm missing 2 here. It didn't do the patching here. And it's actually missing, it may be missing a control point there, but if that's the case, you can come back here and do it manually. Sometimes it doesn't generate it for you, but you can add them manually, right? Because there are control points we could use in the file. Okay? And well, it actually I guess this is the problem. It actually made it everywhere. When I did the patch, it made it everywhere. Let's go back. Yeah, I thought it would just do it on top, but it has some. No, it actually didn't. But why are these closed? Let me see. The back of these folded panels are solid for some reason. Okay, it's because of the pattern, underlying pattern. So let me go back. And let's choose the masking again. Take off the underlying 1-2 pattern. And let's do the patch again. Create component. No, not this one. The I guess we didn't bring it. Component. If it's not here, we could load it. Load family. Desktop. Patch tile. Patch tile. And I should be able to place it here. And this guy I'm going to delete. And then I'm going to choose this and apply it. See if it's applying everywhere, you may have to patch it manually. Yeah, it does. So what I would do is basically apply it everywhere and then try to go ahead and select them manually and delete them. Let's see if I choose this. Well, could we actually choose this guy? Border tile. They should enable you to choose the border tile as something else, but unfortunately not. Okay, any questions about these? How these adaptive components and pattern-based families work? So next week, for next week, I'm going to upload another assignment. Where is that family? So select all instances. That's this family, right? Parametric massing family. So if I choose these surfaces, let's say I want to choose this guy, you can also divide them here. right? And then this surface I can apply a pattern, 1-2 step. I can control the number of divisions. Technically, I can bring in my adaptive component here, apply it to my parametric massing, tilt the parametric massing, and see how those panels adjust, and then bring it as an instance to my project. So I can do all that parametric modeling here. Let's do this one, it's 5. Right? So I can do separate. This one is, I need to change the division of this one. So this guy is 12 by 12. Let's make this one 12 by 12 as well. Right? So instead of using this guy, I could use the folding one I did. So let's bring that. Insert load family. Where is it? Folded panel. Filter, check none. Divide surface. Folded panel. Right. Just doing horizontally. Does that make sense? How it works? And now if I do rotation, let's see, 200, 45, 45, 35. So it's not only going to calculate the massing, it's also going to calculate the new distribution of panels. So it's going to update the panels as well. Because everything is parametrically controlled, right? They're all linked to each other. Okay? So if this panel, if this pattern family is like, could have glass on it, could have solid panels and glass panels, and then all I have to do is basically choose it as a surface treatment, and then play around with my massing family, and then it will be updated.